Hi, let's learn how to use an oscilloscope. An oscilloscope is an electronic equipment that will tell you what is going on with the electricity. It tells you in the vertical scale in voltage what is happening and in the horizontal scale in time when it is happening. If you don't have an oscilloscope, you are just assuming or thinking what is going on, but you cannot prove it. So the oscilloscope is a very important instrument in your electronic equipment, in your workshop, engineering, workplace, or for hobby. Digital oscilloscopes, they are some way somehow allied to the analog old ones. So the first thing we are going to do is to learn how to use an oscilloscope, and it doesn't matter if it is a digital oscilloscope, a smart oscilloscope, or all analog technology. First, you need to know in the oscilloscope you have the vertical scale with a position knob that will move the graphic up and down, and the scale that will give you volts per centimeter readings. In the horizontal, same thing. You have the position that will move side to side and the scale that will give you time per centimeter in the graphics. This is your friend, the trigger, and this is the best friend and one of the more important buttons you will use in the analog oscilloscopes. This oscilloscope has two channels. Some analog oscilloscopes they have 1, 2, or even 4 channels. For the digital one, I have a button to select channel 1 and 2. For the analog oscilloscope, you will have a switch that says DC AC at GND. In GND, you will turn the channel off. Now, let's go to get something here. First, select channel 1, and in your analog oscilloscope, put it in DC or AC and channel 2 in GND. Keep in mind, in the digital oscilloscope, you must tell the oscilloscope what is your probe attenuation, if it is 10x or 1x. Your oscilloscope will know it and will apply it for the mathematical formulas on it. In your analog oscilloscope, you must keep it in mind because you will have to make a calculation with it. Your oscilloscope will not know it. Now, in channel 1, I selected. I will move the menu away by punching the button menu off, and I didn't get anything. So the first thing I have to do is to move the position knob. Okay, I got something there. Now I have to open that image or maybe close it, depending on the situation. Let's move up and down. Okay, I got something there. But so far, it looks like there is nothing stable on it. I will do the same thing with the position in the horizontal and the timing. I cannot get something stable. Oh, I remember. Did I tell you that Mr. Trigger was your best friend? I will tell you why. Mr. Trigger is the one who helps you to get the graphic. What you have to do is to move this knob up and down, and when the trigger touches the graphic will become stable. In the digital oscilloscopes, you can see Mr. Trigger, not in the analog ones. As I told you, the graphic is stable. I can move now the timing and see what is going on there. What happens if Mr. Trigger goes away from the graphic? The graphic is unstable again. There you go. Okay, now I know Mr. Trigger is my best friend to always capture the image. I will turn off channel 1, put it in GND in the analog oscilloscope, and let's turn on DC or AC channel 2 in your analog oscilloscope. I will move the menu away from here, and I got something there. So I will use the position buttons to center the graphic. That's my graphic. In some oscilloscopes, you must tell the trigger if you are working with channel 1 or 2 because the oscilloscope doesn't know it. In analog oscilloscopes, you will see next to the trigger you have a button that says channel 1, channel 2, TV or AC. So to do it right, we have to put it in channel 2. For this kind of model of digital oscilloscope, in trigger I have a menu, and I have the source, and I will tell the source now is channel 2. I will move the menu away. You move it to channel 2 in your analog oscilloscope. I can see the trigger here. You cannot see it in the analog oscilloscopes. And my graphic is unstable. If I go down, out, there you go. That's my trigger. Now I know the basics, how to put something in the oscilloscope, and also that I can help my oscilloscope to capture the graphic with the trigger. What trigger does is to select one point of the wave and as a reference point and start recreating the wave from that point. If I analyze what is going on here, I will make this graphic a little bit bigger to match the screen. I will use the position. Now guys, let's learn to use an oscilloscope. It's very easy. You have no idea how simple it is. Has a lot of buttons. It looks complicated like the old Concorde that has a button for everything, but we are not going to fly that airplane. We are going to use an oscilloscope that is very easy. Did I tell you that the vertical scale is telling you what is going on in voltage and the horizontal when it is happening in time? Okay, now that I make my graphic as big as I could, I am realizing from this point to this point I have one wave. That's what we call the period. Now that I know this is my period, if I move the vertical scale, I can see that my period is repeating continuously one after the other. How many times in 1 second? A lot of times. Wow, too many times. A bunch of times. Okay, we don't use that kind of terminology in electronics. We use calculations, and that's what engineers will love, and technicians too. So let's make it easy and simple. From the bottom to the top in the graphic is where we have the voltage peak to peak, from here to here. So this is very simple. Just count the number of centimeters plus millimeters you have there. In my case, 1, 2, 3, 4, 5, 6 centimeters, and multiply by the scale here in the vertical. So it's 6 centimeters times, in the analog ones, you will get a reading and you will have a pointer in your knob. Multiply times that. In my digital oscilloscope, I will get a reference here. For the analog ones, pay attention to the formula. The vertical centimeters times the scale in the vertical, where the pointer is, times 1 or 10 in your probe attenuation. Remember, if you are using your probe attenuation. So now we know vertical, centimeters times the scale, times 1x or 10x in the analog. The oscilloscopes, digital oscilloscopes, they already know the attenuation, so I don't have to multiply that. Easy. 6 centimeters times 500 millivolts is equal to 3 volts. Now I know there are 3 volts peak to peak from here to there. 50% of the oscilloscope use is already known. Good. Let's go for the other 50%. The time. Did I tell you that this wave from one reference point to another is what we call period, and after that the period is repeating several times per second. So how many times in 1 second is frequency, but the size of the period is what we call the time. Very easy, guys, just look. Same recipe, but what I'm going to do is to use a reference point. As I use it for the vertical, that I use this line, I will move here because I need one reference point to start counting my centimeters. Now from here to here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 centimeters. 10 centimeters times the horizontal scale, what you have here in the numbers with the pointer in the analog oscilloscopes, multiply that. In my case with the digital oscilloscope, I will get it on the screen in seconds. So 10 centimeters times 100 microseconds is equal to 1 millisecond for this kind of oscilloscope in the calibration point. Now I know what is happening. 3 volts are happening here, and when it is happening, this is happening in just 1 millisecond. How many times per second? Okay, that's very easy. The frequency, do you remember we said it was a bunch of times? But we don't use that kind of terminology in electronics. We use numbers. So let's make it with numbers. 1 divided by the period is equal to the frequency. Easy. Now we got the 3 mathematical formulas that help us how to use an oscilloscope, and we are done with it. 1 divided by 1 millisecond is equal to 1 kilohertz, 1000 times per second. There you go. I know what is going on there, what is happening and when it's happening. Now I understand how to use an oscilloscope. Very easy. Friendly. It's important to know, guys, that some oscilloscopes, in the analog ones, they have a little knob here or in the side, CAL. Make sure you may click on it, because that kind of button is like in this kind of model. I have this graphic, but if I want to explore something in the graphic, little detail, I will just move and pay attention, because it's moving just a little bit, just for my exploration. Okay? It doesn't mean that I am in the scale. So in my oscilloscope I have to punch from here, the button, go up a scale or down a scale. 1 volt per division, 500 millivolts per division, 200 millivolts per division. That's what I want to see. In your analog, make sure that CAL is clicked off. That's what we use when you make the measurements. The other one is when you have to explore something little in a very complicated wave. Now let's go to channel 1. And remember, we have to tell Mr. Trigger in your oscilloscope, probably it has to go with reference trigger in channel 1. There you go. I have one graphic there. I will turn on the second graphic, and I have my 2 graphics. Also, oscilloscopes they have a mathematical function. This mathematical function is, let's turn it on, a plus b, a minus b, or a times b. We engineers, we love the a minus b. Why? Because we will get the offset voltage. If we subtract 3 minus 3, supposedly it must be 0. Let's check that. But it's not 0. Yes, that's what we love to see. That's the noise. We are capturing the noise there. And that's what we engineers we like, to fight with the noise, the offset voltage and the calibrations. Now we are done to know about the mathematical functions. Also, we have the reference button that will help us to move the ground point to one part of the wave. In case of you are working with power supplies with plus minus voltage and they are not symmetrical, they are not alike. That's the basics about how to use the oscilloscope the old-fashioned with a calculator, and how to use an analog oscilloscope. Digital oscilloscopes, they have another functions, and we did it manually. Now let's do it in the semi-automatic way. I will turn off channel 2. I will stay in channel 1. Same thing. Let's try to make the wave as big as you can. You have the period. Do you remember in the manual way I have to use 2 reference lines to start counting, like that and like this? Okay, now it doesn't matter where I am. I will use Mr. Cursor. This is a good one. With Mr. Cursor, I will turn it on. I will go to manual, and I will get some bars, 2 bars, vertical or horizontal. I am in the X now. This is the Y, and this is my bar A. Is active, is this one. I will put it in the top of the graphic, and I will lock it. I will unlock my bar B, and I will put it in the bottom of the graphic. I will not use the lines because now the bars, they are my lines, and I will lock it. What do we have here? Oh, Mr. Cursor tells me that from the bottom to the top I have 3 volts, 3.02. That's the semi-automatic way to get a measurement from the screen. What about channel X? I cannot wait for it. Same thing. Channel X. I will punch A. That's my bar A. I will touch my graphic in the beginning of what I said is my reference point from the beginning of the wave. I will lock it. Now my bar B is behind the menu, so I have to turn my menu off. Good. That's my bar B. The blue one is moving. In the end of the graphic. And lock it. Move the menu away. I'm using my reference bars, and it says from here to here the period delta X is 1 millisecond, what we did with the calculator. Oh, and the frequency is here. 1 divided by delta X is equal to 1 kilohertz. That's the semi-automatic way. So now we know the manual way that we have to apply with the analog oscilloscopes, and the semi-automatic way to get information from the screen. This is very easy because it's just one wave. Sometimes we have a very complicated wave, and that wave has information in between, and we need to use the cursor to get data from it. Now, let's go for the automatic way to do this thing. Mr. Cursor, thank you very much. We will turn you off. The automatic way is punch measure voltage. I want the voltage peak to peak. Select is 3 volts. Time, I want the period. Select 1 millisecond. And time, I want the frequency. Is there? Let's move the menu away. 1 kilohertz. Easy with measure. Now we also have some extras like display all, and all the data is there. I'm getting here information, the voltage peak to peak, the difference between one and the other. As you see, the wave always moves a little bit and has some tolerance. So I'm getting all that information here for analyze. I will turn measurements off, and I'm back to it. What else can I do with this stuff? Okay, I have the storage button. In the storage, I will go to internal. I will select one of them. I will say 9, and I will save it. Now this information is disconnected, but the information I added there is still there. Let's see it. Storage internal, because it's the oscilloscope memory, not the USB that is external, and I will go to 9 and I will load it. Voila, my graphic is in memory. I can use it for information analysis, put it in a document, or anything else I will need. Easy and friendly. Channel 2, and I will get my 2 graphics. Digital oscilloscopes. Channel 1, reduce this one, position. Digital oscilloscopes, they will give me an extra function. Is the auto button. I use the other ones because I need information from the wave. Auto button will help me only to get the trace, but probably it's not exactly what I need. Let's punch it. I got a graphic. So for hobby, it's okay. It helps me a lot. I don't need to learn how to use an oscilloscope. But to analyze, I have to do it as I did it in the beginning. That, guys, is the basic of how to use an oscilloscope. We can go later for another video in more complicated things. Remember always, Mr. Trigger is your friend. If Mr. Trigger is touching the graphic, you will get something stable on the screen. If it doesn't, it's out of it. Also, Mr. Trigger has a menu. As I said, in the analog oscilloscopes, you have channel 1 and 2, and you must always use the reference. Sometimes I have to inject a signal and work with it. So my reference or my source will be the external one. You have also the AC line, and some oscilloscopes, they have in trigger the TV signal too. In the most important things, that's the way to do it. I can use the trigger in manual way or for a single trace. Digital oscilloscopes, they have auto. In the analog oscilloscopes, you also have a pull button or a punch button for auto trigger that will help you to find immediately the trace. But anyway, you will have most of the time to move your trigger up and down to touch your trace. Now guys, you know how to use an analog oscilloscope and digital oscilloscope. Go and enjoy it. Thanks guys for your attention. Don't forget to click on the ads down or on the side in the beginning or the end, because the sponsors, they are the one who keep this channel for us, and it's good to know what they are showing too. So it will take you just a few seconds for us to keep the channel. Thanks by watching.